Hello friends, this is a short video to mark the 1000 number of subscribers in the channel. Nowadays 1000 subscriber is not a big thing because people have in their channels million number of subscribers, but the topic here is different. It is not a political topic, it is not a defense related analysis topic and so on, but it is a very hardcore topic of the performance-based seismic design. Now question may arise, why should we go to performance-based seismic design? Because design courses are always there in every country. Then why do you extra require a new formulation, a new type of design philosophy in place of the course? Now the human society understood about the earthquake only recently, say around 200 years. Earlier, earthquake used to come, destroy the things, and people were in bewilderment. Gradually, they understood that an earthquake produces some horizontal force in the structure, and as a result, because of the inertia forces, there happens the damages in the structure. About 150 years back, a Japanese engineer conjectured that the amount of horizontal force that is generated through earthquake may be taken as 10% of the weight of the structure. And that was the start of the seismic engineering. Gradually the course evolved. The Codal method uses the dynamics of the structure in terms of the time period. So response spectrum was generated and the first mode time period was taken as the time period of the structure, and the whole weight was taken to calculate base shear. But later on it was understood that only first mode cannot contribute to the whole dynamic behavior of the building. So response spectrum method was developed, which incorporated the effects of other modes, first, second, third, and as many modes you require, so that the dynamic characteristics of the building is captured to the maximum extent needed and felt. But then the problem was still there. What is the problem now? Problem is, even after the buildings and other structures are designed using the prevalent course of the countries, the structure continued to fail under great earthquake events. So what was the problem? Some basic flaws are there in our codal design. The code assumes that it is the force which should be regulated to regulate the earthquake performance. That is why it gives the importance factor. For more important structures, it uses higher importance factor, and that requires higher cost. But the question is whether higher performance is guaranteed through the higher cost is not visible, not verified. So alternative philosophy was to be found out, and it was suggested that instead of force, use the displacement. Now if it is a elastic structure, then whether you use force or you use displacement, the result is same. But your structure undergoes linearity. After a while, the earthquake strikes the building. And in the nonlinear condition, the design through force and design through displacement are not the same, they are different. So it was suggested take the displacement as the criteria for design, and various displacement based design were evolved. One was the direct displacement based design, which could address the drift as the design criteria. Now performance based design is a design where you choose your targets to be achieved in the beginning, and you go on by using the engineering, mechanics, structural dynamics, and the design engine to achieve the structure. So there was a limitation with the direct displacement based design. It could address only one target objective, that is drift. So research went on and came the unified performance based design, which could now address two target parameters, drift and performance level. Performance level is nothing but the damage you allow in the structure. Depending on the functionality of the structure and your aim of the design, you can use small damage, medium damage, or large damage, and the corresponding buildings are called IO, LS, or CP. So depending on your requirement, you select the performance level depending on the requirement, you select the drift, and then you design the building for these two parameters. So far as we stand today, two design parameters can be achieved through the performance-based design, through the unified performance-based design. In future, maybe other things also will come together, like strains, then crack widths, and so on. So future scope is there for further development. So I thank you all who subscribe the channel. Today we stand at 1000 subscribers. Maybe tomorrow gradually it will expand. But it will be far away from monetization because the watch hour is not very large. It is only 1500 hours. A minimum watch hour required is 3000 hours in one previous year. So thank you all for joining, and see you again in our next videos. Thank you.